Okay guys, I'm ready about to get started in a few minutes, like less than 2 minutes I guess. And here I'm just setting up a little bit of making sure connections are correct and streaming through properly to various channels. You should be able to see me by now and hear me. So what we'll do is continue our uh, discussion that we had the other day. The last time we streamed, we briefly discussed what's a virtual private cloud in a conceptual fashion. And what I want to do today now is, first thing, get rid of this timer. So the timer countdown, I get rid of it. Let me get out of it. And then see if we can begin our discussion with live examples right now. So let me clear out this chat that's happening right now, and get rid of the chat window altogether. I think that's better. So I think I am having some difficulty right now, apparently, with Google misbehaving. Let me fix that, and this should fix in a moment. There we go. That should fix it. It didn't. Now it did. Okay, so I think we are back in business. Quickly checking a couple more things. I think we are good. So this should give us an opportunity to start or rather resume the discussion we had the other day about virtual private cloud. And let's begin with a quick recap. The last time I mentioned about VPC, or virtual private cloud, I compared it with your typical home network. You have in a home, you have a thing that you already know. You have an internet connection coming from outside, like a Comcast company, or some cable company, or some DSL company, or anybody who provides internet service. It can very well be Elon Musk Starlink. Elon was awesome just yesterday, Saturday, and he opened up Starlink for Ukraine in 10 hours since some minister or some leader from Ukraine tweeted at Elon saying, hey, we need Starlink in Ukraine, and Elon within 10 hours enabled the country and sent a whole bunch of Starlink equipment for that country to continue to access internet in spite of adverse situations. And that is internet services provided to you from some provider. So just take the example of Starlink, because I think Elon is awesome. And so Starlink, basically it's an antenna that looks at a satellite and gives you bidirectional connection, up and down links. So uplink, downlink, and gives you basically a modem, a modulator, demodulator. And that modem you connect it to here you get public IP address from your internet service provider. Starlink is the exact opposite of Comcast. Comcast sucks. Comcast is cheaper, I guess, compared to Starlink, and bandwidth is a whole lot different scenario. I think Starlink is not comparable to the extreme height of bandwidth that we get from a local connection, like a cable connection. But Starlink is good enough for even video streaming. It works nicely. Having said, that endpoint which gets you the internet is your public internet or public IP address. What does that mean? It means here the addresses at this point, at this location, the addresses at the public facing endpoint can be any number as long as it fits in these boxes, and each of these boxes can range from 0 through 255, and put any number you have, and that's your address space. And there are some exclusions, like we discussed the last time. The exclusions are carve outs for private IP address ranges, and those are the 10 dot whatever, the 172 dot something, and then the 192.168. whatever. These are the three ranges that are carved out for private address spaces. Anything else is public. So that address is what you get from your internet company after they give you a modem. That's where you get the public address. Now you take that address, put it through a router, and here you get your private addresses. And you can hook up your PCs or Macs or whatever else, and even Wi-Fi wireless connections to your wireless devices. And those are all the devices that are in your private area. So that is the example that we will now play with in the context of a cloud. And so yes, you will, let's make sure that I can connect to a cloud company. So here is a cloud company, and this is your Amazon cloud. We have chosen the Oregon region. This is my favorite region, as you probably already know. I always like to work with all the exercise that I do. I usually go here and work through that because it, I think, helps me in making sure that everybody who's doing these exercises with me are on the same page. So we just prefer that region for practical reasons, is that just be on the same page with everybody else who's doing the exercises, so that we don't confuse ourselves. In fact, in case of Amazon, these are completely independent clouds. You can have a separate private public key for each of these regions. So I would treat them, each of these regions, as separate clouds, even though Amazon likes to call it one cloud. But they're not designed like that. In fact, they began with, where is that thing? US East 1, somewhere here. Yeah, that US East 1. That's how they began, and then slowly created other regions, and now worldwide. And there are some ways that they behave differently from most other clouds, and so we'll talk about that later in a separate video. But right now, let's focus on this region, Oregon region, US West 2. So make sure you select that one and work with that. And I have chosen that already. You can see that I have chosen Oregon as the region of my choice. Now in this region, Oregon, I have to look at my VPC dashboard. So I'll go to the Amazon top and then look for VPC, and here you will find that I have one VPC, and I have labeled it as don't use, do not use. So ignore this one. Ignore. Don't use anything that is given to you by default. That's how I operate. I create everything that I like the way I want, so I can understand what I'm doing and also maintain it over a long period of time. And that's the reason why I don't take whatever people just give me ready-made. I don't like that. So I create things on my own. For example, this is the one that was given to me by default, and I will ignore it. Instead, I will create a VPC. So like this, click a button to create, and when I give it a name, so say for example, this is the name of my VPC, and it is expecting me to give an IP address range. So that number you see is a good one to play with. So just take that number, 10.0.0.0.24. That becomes the range of addresses that you get to create inside your VPC, a virtual private cloud. You can go with that, or you can go even bigger. So if you want to go a bigger address block, you can choose 10.0.0.0/ something like 16 is a bigger address range. You can go even bigger, /8, and that's 16 million addresses inside your virtual private cloud. I don't think Amazon allows that, but Google does. And so certain clouds behave differently. Let's go see what the biggest that we can get with this particular cloud, Amazon cloud. So 10.0.0.0/8, and I think Amazon will complain that 8 is not allowed, too big. I think they'll complain, but maybe they changed. So let's go find out what happens when I try to create a new VPC segment like this, and then put an address range 10.0.0.0/8 and create. It says no, not allowed. It's too big for Amazon, cannot handle. Fine. So we'll reduce the address ranges, address space that we want to allocate to our home, or rather VPC here. So that number that you have, we'll reduce it to a smaller number. So something like /16 would be a good one. So I'll go with that. And then I create that VPC. So it creates it. Now I have a VPC. What did I just create? Basically an outline of what I would like to call myself as my private area. That's it. So effectively you created something like your home. That's it. Nothing inside yet. Just a skeleton outline that this area belongs to me. That's the name. And this is your address range 10.0.0.0.16. That basically means you can have any number of addresses that can fit in this two boxes. Anything here, anything here. The simple way to think about these CIDR notations, they can be complicated to understand if you if you're new to this. So the simple way to think about these numbers is, the best way is to go Wikipedia and read. But if not, simply speaking, it is like this. If it is 10.0.0.0/8, that means you can modify this box, and this box. If it is 10.0.0.0/16, that basically means you can modify the last two boxes. And if it is 10.0.0.0/24, it means you can modify only the last box. And that means in this last box you can have any number between 0 through 255. That means the number of addresses in this range, in this CIDR block, is very small. It's like 256. In here it is 256 times 256, and in here it is quite a bit bigger. That's the simplest way to think about these CIDR block numbers that you can see. /16 actually is bigger than /24. That's how you can think of it. You can read more about these things in great detail on Wikipedia. Just go search something like this. So search like CIDR notation. Actually just CIDR, that should bring it up. CIDR notation, Wikipedia. Where's Wikipedia? That should bring it up here, and that will define exhaustively what these things mean. So we're not going to that detail yet. No, there's no need to for right now. We'll just pick one of these ranges that we chose. I think we chose the /16 here. And that's the size of our home in Amazon Cloud in Oregon region. That's the idea. So let's go check it out. What I want to do now is to see what we actually get when we got that home allocated for us inside our Amazon VPC. So this is the name of my private area, and I have my address space defined by the CIDR notation, like right here. That's the beginning step that we did. Now what I'll do is walk through this list of things that you can accomplish inside your VPC to understand how do you construct your own private area, and how do you make use of it, and how do you maintain it. And then in a subsequent exercise, we'll do all these steps that I'm doing right now manually. We'll do it with automation, with like one line of code, and you can have the whole thing created, whole thing destroyed, and do it again. So you really understand what's going on, because you programmatically create these things as you want to go it bigger and larger and more scalable and repeatable, and be able to do these things without making mistakes. So that's the idea of reducing mistakes and automating things so that you can predictably accomplish what you want. With that said, let us understand the next topic here is to create subnets. Subnets. So what's a subnet? Let's go understand that part. And subnet is nothing but subset of a net. That's a subnet. And so we know that we have chosen our entirety of our network inside that thing that we saw has a range of 16. So lots of addresses that we can put any number we like in these two boxes. Of course, the limitation is you can put a number only that fits in this range. And so it's a large network. We have about 256 times 256, that many addresses, lots of addresses available to us. The address space is big, reasonably big. So in that number of addresses, we can carve out a subset, and that subset is basically the subnet. So we can create various subsets of this network. We create portions of that. So imagine this range, and we have 256 times 256 addresses. That means we can potentially divide this 256 times 256 into portions of smaller networks, each one of them constituting 256 addresses, and we can have 256 such addresses or address spaces. So that's how this thing comes up. 256 such subnets can be created out of this big subset that we created in our virtual private cloud, in our private area within the Amazon cloud. So the way you represent these ideas would be something like this. Now that gives you the flexibility to create an address range that begins from this number all the way through. That means in this range of numbers, we have 256 addresses. That becomes a subset of the bigger network. This is the representation of this range, and our full network is bigger. It's 10,000/16. It's like 256 times bigger than this network. Another subset can be, and again I'm going very simple examples right now, but it can be something like this: 10,010/24. And this basically also contains 256 addresses, and those addresses will be 10,010 through 10,01255. There are 256 addresses here again, but this is a different address space. And like that, you can modify these numbers to create a different subnet out of the full VPC that we have carved out. So that's the underlying idea behind a subnet. So now let's go back here and see what we can create inside. There are some given subnets already from the other VPC that I don't want to use. So let's go filter it. Filter what? Filter the one I do not want to use, so filter it out. That means this name called ignore should be filtered out, and the name called Cloud Genius should be kept. So now when I filter only the ones that are Cloud Genius VPC, I don't have any subnets in the Cloud Genius VPC. I don't have any. And that's exactly true, because we created it like right now, so there is nothing in it. Having understood that part, what I would like to do is to make sure that I create some subnets. So I have a few ideas that I can create. Maybe I'll create a couple of subnets, but before that, before we jumping into the idea of creating subnets, I want to help you understand why do we create subnets. So the idea behind these ideas of subnets are to create separate areas for things that you have inside your home. If you remember, from our last session, I talked about my home, in which I have an area that I call my home network. That's where I have this PC, Mac, whatever this thing is, right? This machine where I'm writing on, this machine sits on my home network. And then I have another network called crap network. This is a larger network that contains a whole lot of crap, useless devices. Actually, they're useful, but I don't trust them. So I put them on a separate, isolated area. I call it the crap network. That's where all the junk from China goes, all these IoT devices that I have. And basically I don't trust the firmware that these guys have, so I don't let these machines here connect to anything inside my home network. Not allowed. So that's the idea of isolation and separation between and one subnet from the another. Or you can put such firewall rules anywhere you feel like, and you have to write these rules yourself. But that's the underlying concept of why do we create subnets, is to separate things into various buckets and isolate them from each other. That's the underlying idea of creating subnets or subsets of the network, to isolate crap from what you like. You can still use crap if you like, because I actually do. And so an example of that crap network device would be something like this. Here, you see, that's a crap device that is looking at my neighbor walking his dog. Look at that right there. See, this is like front view of my home, and I can see my neighbor walking his dog. So that's an IoT device, front facing camera looking outside. And I don't trust that camera because I don't know who wrote the firmware and I have no idea. So it sits on the crap network. I can see and access those things in that network, but these network devices cannot access and see what I have in my home. That's the one-way firewall. I can see that what they're doing, but they cannot see what I have inside. They're both in my home, but they're isolated. I hope you get the idea. The idea is to basically filter, to regulate what you can, and isolate things that you don't want from things that you want. And you can decide what want means. And so basically the idea would be, put certain things that you want directly connected to the internet outside, public internet. Yeah, directly connected. For example, your router, it is directly connected to the public internet, and it in turn then gives you a private area. This can be one of the subnets. Now, sophisticated routers can have multiple subnets created. And by sophisticated routers, I don't mean expensive routers. I mean sophisticated routers. What I mean by that is something like this. That's a sophisticated router software. It runs on a PC box inside my home. So you can see when I log in that it has a bunch of subnets that I created and carved out. We'll talk about this later, but this is like extensive in itself. This is called pfSense software. It is open source based on OpenBSD, I think, a FreeBSD, pfSense.org. Now this piece of software is awesome. It is how I basically learned networking. I did not take CCNA or whatever the stupid courses from Cisco and Juniper are. I don't need to, because these people sell expensive software. But I know all of that because I experimented everything myself using open source software. And so that's how I learned, by doing. And so this is open source, and that's what CloudGenius is built out of, purely using open source. Now you don't need expensive Cisco or Juniper network software to get their protection that these guys provide. You don't need them. All you need is open source, and that's more than enough, by the way. And with using open source, you can build whatever you want for yourself for cheap, like really cheap, sometimes even free. As long as you have time and dedication, you can build whatever you like. And so let's roll back to this idea about what are we trying to accomplish, is to create various subnets. So this becomes one subnet where you can put your application servers if you like, and in this subnet you can put something like your database if you like, database servers. Like, that's one example. Another example would be, in my home case, I have my actual my home network in one portion and my crap net in another portion, and you can create different subnets. You can allow traffic from here to here, but don't allow traffic originating from here to there. So don't allow this, allow that. And you can set rules like this as to what can access what and what cannot access the other way. And so that was the home network example. In case of a more realistic cloud example, you will create one subnet for your applications. You create another subnet for your databases. You create one more subnet for your public facing items that you may have. And here on this subnet, you will put your router. On this, you will put your application machines that run your application. So M1, M2, machine number N, like that. You can have any number of these machines sitting on this subnet. In here, you can have one or more database servers, or you can have something else, depending on what your need is for the application's architecture. These become your subnets: public subnet, application subnet, database subnet. And that's how you start thinking about creating subnets. So to create a subnet is simply, setting aside some address space. And the grand scheme of things, the address space that we have available with us is this. It's a large space. You can carve out a portion of that into, say, 2 parts or 3 parts, and this becomes your public range of addresses. Public. And this can be your application subnet. So the range can be something like 10.0.1.0/24. This can be your database, or let's not complicate it. Let's not do this. Let's just keep it simple. 2 parts, 2 subnets. In fact, this we should not call it app, we call it private for simplification. So just public and private, 2 subnets. No further complications for right now to begin with. Keep it simple. 2 parts. This is a very large range of addresses. 256 times 256. This is only 256. This is only 256. So it's a very small subset of the bigger set that we have available to us inside our private area. We'll create these 2 subnets with the intention. The intention is to let this connect to the world outside, and these guys remain private. That's the idea that I'm going to begin with. And so let's go there and create a subnet and make sure I filter properly and filter only the CloudGenius VPC, and then I don't have any subnets. So then I create a subnet, and the created subnet will be in the CloudGenius VPC, not the Ignore VPC, but this one. And here I can create a subnet. I call it private. And there I can choose my range of addresses. Like I would like to choose this address range, 10.0.0.24. So I'll go and select. Now these suggestions that Amazon is giving is kind of dumb. That's don't select that. It should be 10, not 1. Yeah, that's a good one. 10.0.0.16. That should be 24. Like, see, that's the idea. So let's take that and then call it private and then create. That's it. That's all it takes to create a subnet. So this becomes your private subnet, and you can see that it has the range that you wanted. What did we want the range to be? Here, 10.0.0.24. And now the other one will be this private subnet. So create that basically by clicking create subnet in this VPC called CloudGenius, where we will have a name for this. I'll call it private, and then put in put in type in oh, that was a bad dumb joke, but yeah, it's on top of everybody's mind these days apparently with the disaster is created. So Forget that, put in business. Talk about this number 10010/24. So 10010/24 is what we want. So we take that and then create a subnet. So now we have two subnets created and we'll see them here. We'll see both of them. Did I name both of them private? Apparently yes, this should be named public, so I'll rename that. It should be called public. For the number based on my convention here, I call 10000 as public, so I should label it correctly. Let me fix that. This name should be public. In fact, that brings up a good point. These names can be whatever you want. You can call it monkey, donkey, doesn't matter. Their names are irrelevant. It's for you. Absolutely irrelevant are these names. They're for humans to understand what they're doing. Not, even if you, in fact, just to mess things up, you can call it public. But don't, it will confuse you. So let's go back to the private naming and call this monkey as public, and then at least it makes sense. But the point is, these names do not matter. What matters is what I'll tell you now, how you connect. How do you actually connect the cable? Yes, we are talking about some cable connections between you're talking about getting a router and putting it in this location in the public subnet. We'll do that, by the way. We'll actually get a router and go to Amazon. I'm kidding, but we'll practically accomplish the same idea without going there. So the next idea is to get some internet service into our private area. That idea is called gateway. A gateway is basically something that brings you the internet. Like Starlink in Ukraine is a gateway to the internet for them, even though Russia seems to have cut off their internet, or maybe they're about to, or I don't know what, but they requested internet. Starlink comes in, gives them internet. It's the gateway. And there is already a gateway given to me for the other cloud, for the other VPC. So I want to ignore that. So I'll just filter it out. So I'll stay focused on Cloud Genius, and I don't have a gateway. So let's go request Bezos Baba. Can you please give me a gateway, internet gateway, please? And he'll gladly give it to you. So this is the gateway that he's assigned to us. So you can see that the gateway issued to me for my VPC is this one, detached right now. So I need to make sure that I attach this gateway to this VPC. I need to do that. Let's do that piece so that it gets connected to my virtual private cloud. Let's go fix that. We'll go to that gateway. It is currently detached. So we will say action and attach it to the Cloud Genius VPC and say go connect. So that's the wiring or connection that we just established between what? Between the VPC that Bezos Baba gave us and wired it up so that we get internet service inside our private area. So that's the wiring, one way of connecting things up. There's no actual physical wire, it's all virtual done through software, but that's the IGW internet gateway that I got for my Cloud Genius VPC from Bezos and connected to my VPC. So that's one beginning idea. So now let's draw what we did. We requested a VPC. In there we created a subnet and another subnet, called it private, called this public. That names do not matter. And then I got an internet gateway. Actually this line is drawn incorrectly, so let me erase that line. Yeah, we just got it, internet gateway, so that internet is available. We haven't actually connected it to either public or private subnet yet. So that's the gateway available. We can use it connected to the VPC, but not to any subnets yet. Now let us see what do we need to do. We need to get a router that you know already how it looks like, something like this. Yeah, those boxes. We need to get one of those boxes, and you know, maybe get this one, D-Link, and tell Bezos to, you know what, can you please take my router and connect your internet gateway to the WAN port. One of these, I think they're WAN ports, this or that, two of them, and there are 4 outputs that can go connect to the internal things inside. So the practical thing is that you cannot do it this way. You cannot ask Bezos to take this. I don't know, it's not Bezos anymore, there's some new guy who's the CEO of Amazon. So that guy will not accept your device, but what do is that they actually give you a way to connect a router. Now this router is available on Amazon already. We'll make use of it, and later on in another session we'll create our own router using like few lines of code. Create your own router. It's totally possible. Quickly checking sound. I'm getting some feedback from people about sound, so making sure that I can transmit the sound correctly, and I think the sound is transmitting just fine. So no, there is no issue in sound, as I can see, and it is streaming, I think, okay. Stream is sounding okay. If you have issues, please chat with me on Slack, but I think the stream is going on okay. Let me see. Yeah, the sound is okay. Yeah, thank you. Yes, okay, let's continue. So what I want to do now is, in our VPC, which is called this Cloud Genius VPC, we have 2 subnets, is public and private, and we need to get a router. A router is basically a computer, and you can get one through EC2. EC2 is the Elastic Compute Cloud from Amazon, and here you need to launch a machine instance from Amazon, and mount it exactly in the location you expect it to have, which is on the public subnet. You need to get a computer running here. That's going to be your router. So we'll actually get a prepared ready-made router and mount it right there on the public subnet, and I will do that right now. For that, I need to search which machine should I get. There are lots of machines available, like this Amazon Linux, another Amazon Linux, there's Mac OS, there's Big Sur and Catalina and all that. So basically these are operating systems images available. I don't want any of these because they're not a router. So we would like to find some routers. They're available in the community AMI, and we need to search for it. Search for NAT and put in the word number I will never use that word again, sorry. 2022. Type in the number 2022 for the current year, and you will probably find some images that are ready to use, that can be used as your router. NAT is network address translation. So here are 15 example images that can be used to create a machine that will behave and function like a router for yourself in your VPC. So let's go see which one of them is the latest one. I'll pick the latest one out of these guys, and then begin with any one of these selections. So this is a 2018.03. That's not a good one. It's fairly old. This is old. This is also old. So let's go latest. Any? Where's the latest one we have? NAT Java, no. 2022, no. Native Selenium. Apparently we don't have newer NATs. So forget the 2022. we'll just go with whatever we can get. In fact, I would like to choose something like AMZN, AMI, VPC, NAT. Let's go search for that string and see what do we get. We got 74 examples. Let us see if we can find a newer ones. One of these guys, they're all older, apparently 2018. Looks like Amazon is not maintaining newer versions. That's fine with me. The reason it's fine with me is I actually don't use these images. I create my own NAT, and you will see how we do that in just a few lines of code. Just take a plain vanilla Linux machine and make it into a NAT device, a router device for yourself, and you can see that how to do it. We'll do that in a subsequent exercise in another day. For right now, I'm just going easy. I'll pick one of these guys, 2018. I think it looks like the latest. Apparently they have updated the dates here. They are updating. Okay, so that's the date to update. So yes, you can see the dates are confusing. We have 2018 and then 2022. So they're taking an old image and just putting an updated date on it. Apparently they're not rebuilding the new images from fresh. So I think this looks like the latest image available. So I'll go with that. Again, the search string was Amazon AMI VPC NAT. That's a ready-made Amazon Amazon Linux version that is configured as a NAT, as a router. NAT basically means network address translation. So that's the image I want to choose. I'll select and I'll create a new machine inside our CloudGenius VPC. So I'll select that. Here I will say T2 Micro. That's the cheap and also free to use image. So you don't have to pay for it apparently, because it is under the free tier. Many of you actually have a free tier account, so make use of it. Don't waste money. Use this one. When I click, I'm not getting it for free, but I've been using Amazon Cloud forever. So this one is not free for me, but definitely free for you. Most likely, just check your free tier pricing. And here I want to make sure that I choose the CloudGenius VPC, not the other one, this one. And I want to make sure that I select the correct public subnet, not the private. This one. And then you want to connect to this NAT from the outside. So you have to pay attention to these things here. Automatically assign a public IP. What does that mean? It means that your machine that you are going to create gets a public IP here, like that. So you need to create a new machine, and it gets an IP address on the public address space, public internet. That's what you want, and that's the reason why you want to make sure that you carefully select this button, automatically assign public IP, and you say please do enable. That's true when you're creating a public facing machine like a NAT or a router in this example. And then go to the next step, click and add some storage. And please don't get magnetic storage. This is kind of dumb. Don't even know why they give it to you, but apparently they do. So just choose this GPT-203, one of these guys. They're good. General purpose SSD 3 or 2. There are probably some performance differences in the two, but doesn't matter. Just pick GPT, general purpose SSD number 3. That way a good guess. Let's see, the numbers IOPS are 3000, throughput is 125. Compare that with GPT-2. So throughput is not guaranteed apparently. So let's go with GPT-3, and then you go to add some tags. We don't need to add tags, so you can skip that portion. Configure security group settings. Now here you want to be able to connect to your NAT from the outside, so you want to allow a firewall rule so that you can access your own NAT, your own router from the outside. You are not in that location, by the way. See this location? You're not in there. You are outside in your home. You see? In your home, you are here in your actual real physical home with your laptop, desktop, and you want to be able to connect to this NAT, and therefore you need to get a public IP so you can connect from your laptop to your NAT. You want to be able to use your network in this virtual private cloud, but you are not there. You're not in your home. This is not actually your home. It's a virtual location. You are here. This is you, and you not here. So you cannot just assume that you can get access. You cannot. You will not get access unless you allow a route like this, and we'll draw that route and actually make things happen. So let's see how it works. So for that, for you to be able to access your own infrastructure, you need to create a security group. Let's call this one our NAT security group, and this one allow me, just me, to access my NAT. And here you can allow port number 22 and allow just me. You can go like that, or this can get complicated for people who are like doing this exercise from multiple locations. So I would rather not limit to just one IP address, but allow access to my NAT, so that you can go to Starbucks and still access your NAT. That's the idea. So you're at home or you're at Starbucks, you can continue to access your own NAT. That's the underlying concept. And we will now review and launch. And when we launch, what do we see? Is that it doesn't give you a key pair because we never created one. You see, no key pair is found. So you need to actually create a key pair to begin with. A key pair is something that you remember from a previous exercise we did, is you need to have a key pair created for yourself using something like this SSH keygen, like that. You need to create a key pair like that by pressing enter and then saving it in a file. Let's call it Amazon, and then no passphrase and exit. Now you should have a file here called Amazon somewhere in your location, in your local computer. In this directory you should have a file called Amazon. Do we have it? Yes, we do. So that's the file called Amazon, and this is the file called amazon.pub. These two files got created right now. I'm going to move them, Amazon and amazon.pub, to this default location where it is expected to be present. That's the directory .ssh folder is where keys are expected by default. You can change the location if you like, but that's the expected location. So we move them to the right location, and now we'll take the public key from here, from our computer, like this, and give it to Amazon. I'm going to copy that public key and go to Amazon and say begin from the top, go to EC2, go to my key pairs like here, and action import my key pair. This one is the Amazon key pair, and here is the paste that I pasted from the public key. You remember this public key that I have, .pub, I am giving it to Amazon, and there I import the key pair. Now Amazon has my key pair, this one. So I can now begin again to create a NAT. So let's do it again now. In your EC2 section, you go create a, sorry, not key pair, brand new machine instance, so launch an instance. In here you select for community AMI and say Amazon the keyword is AMZN-AMI-VPC. That's the keyword, and we select not BPC but VPC. There we go. And then we select the latest one, which is this number apparently. So we select and we go and choose the machine size. T2 micro is good, free. Choose the correct VPC right there. Choose the public subnet. Get an IP address enabled. And then add some storage. Choose GP3. No tags needed. Configure security groups. We create a new security group. We'll call it NAT. Allow access to the NAT from anywhere on the internet. So you can go to Starbucks and still continue accessing your NAT if you like. Then we review and launch. And we launch this machine and select our Amazon key pair. And we acknowledge that I have the corresponding private key, which I do. Here is the private key that I have, that one called Amazon. I have it in my computer, so I can use this private key to access my NAT. So I launch the machine, machine gets ready. And what did I just do? I now have a computer, this one, and it is going to get an IP address soon. So let us get the IP address and write it down. On the public subnet, we have a new machine and it has an IP address. The IP address is this one, whatever that number is, ending in 196, that number. So we need to make a note of that. And this machine, your network address translation machine, has a public IP address and you can access it through your gateway, getting inside to your NAT machine that you created. Let's go test whether we can actually access our own NAT or not. Let's go see that. So this is the IP address that we have. I copied it. I will add my Amazon key into the keyring, which is done by SSH add. And then I can just use the command SSH and then connect to the computer with this IP address. And I skipped one critical thing. How do you know what to type before the IP address? That's the question, which is what's the username for that machine out there in the Amazon cloud? How do you find that out? I just told you it is EC2-user, but how do you know what's the username? And so the way to find that out is to do a what is the username for Amazon Linux AMI, and the answer is not in this search. I guess we have to switch over to Google search to get the right answer quickly, but I know the answer is this EC2-user. So the question to ask is, what is the username for Amazon Linux AMI in Amazon Web Services? And the answer is there, right there. That's the answer. That's how you can find what to put in here, EC2-user. And now that our machine seems to be running here in the dashboard, there is a running instance like right there, and I should label it so I know what I'm dealing with. This is my NAT, also known as router. So I save it. So that's the machine running in my public subnet. You can see that the address space is this. Let's go explore that. See, the number is 10.0.0.165, 10.0.0.165. it is in the same range of addresses that I assigned for my public IP address, sorry, public subnet, which is also known as which is also represented by this range of numbers. In these many addresses, that is, there are 256 addresses in that range, this is one of them. This is one such machine on this subnet. This is the CIDR notation. This is the box notation. This is my notation. Nobody else uses that apparently, but that box is where I use to write whatever I want here and here, and that's my notation. So this box, the NAT router box, sits on your public subnet, and let us see if you can connect to it going through the public IP, not the private IP. You cannot access the box through a public IP, private IP. You have to use the corresponding public IP. You cannot just type in 165. I'll write it again. You cannot, instead of this number, cannot use cannot. Why? Because you're here and this number is a private range of addresses, so it will correspond to something you might have inside your here location, inside, and not what you might have in your VPC. It can be a separate private area. Basically what I mean to say is that these private ranges are not accessible on the internet. You have to go through a public IP. That's the reason why we got a public IP for this guy. So now that we have the public IP in hand, we'll make use of it to connect to it like this. And we have to check our security groups. Did we configure security groups correctly? So let's go check our security groups and focus on the NAT security group, and let us see if this one allows us to connect. I'm going to examine the inbound rules, and the rules allow me to go connect through SSH from any location on the internet. Yes. So 0000 shows you any location you can connect through port number 22, and this should let me access that machine for myself. Apparently that is not what is happening right now. That sometimes happens when you're using cheap machines out there on the Amazon cloud. Cheap machines like I just used, like, you know, the T2 Micro. The check seems to have passed, but sometimes these machines misbehave. Let's check a couple of more things before we jump into conclusion that the machine is misbehaving. The cheap machines sometimes tend to misbehave. They don't actually function like we expect them to. And I've seen this many times. So I think we have a major problem. I forgot a couple of other things which are important to create along in creation of a VPC. That's the reason why it's not working. I think the machine is okay. The machine is okay. I forgot to do the route tables. That's why it's not working. So let's create the route tables also, and I think that should pick up, create the route. What I mean to say by clarification is that we haven't actually created this route table for the routes to reach to this subnet. We haven't done that piece yet. So let me do that piece before we attempt to connect. So what a route table is basically a table. A table means a list of things. So a list of routes, route number 1, route number 2, like that. And those, you can have any number of routes defined in a table, and that's the idea behind a route table. You can have a route table for every such subnet. And let's go see what the table will look like or should look like for our own VPC here. So let's go filter first, filter properly, go to the CloudGenius VPC, and then look at our route tables. We have been given 2 route tables. This one is something that I do not want to use, so do not use. And another one given to us I do not want to use. So what do? I want to create my own route tables. So I'll begin creating a route table for my public subnet, this VPC, and then here I create a route table like that. That table contains nothing much right now, and so we have to associate this table with a subnet. So how do you do that? You associate, you go to the associations and edit the associations and make this route table associated with the public subnet, and you save that association. What did I just do? I created a route table which is an empty table to begin with, and then I made an association between the route table and the subnet. So they're together now. They know that this route table belongs to that subnet. Now in that table I will create some routes. The routes will be, to begin with, is given to us one local route, so you can go traverse from anywhere to anywhere as long as you are within the subnet of the VPC the entirety of the VPC, which is this 10.0.0.0.16. That's where the entire VPC address space belongs. You need to edit the routes and expand the route to allow it to connect to anything on the internet. So you have to add a route, and here you allow anywhere on the internet using our internet gateway, this one, and then save. That expands the route table with one more entry, and let's go examine our route table. We have 10.0.0.0.16, which is access to anywhere within the VPC, local access. These two entries in the table, the first one gives you local access to the VPC active, and the second one gives you access to anywhere on the internet using the gateway. This number representation of 0.0.0.0/0 basically represents the entire internet. So that is what is meant here. You can get to anywhere on the internet using your gateway that Amazon gave you, is active now, and that route table is associated with your, explicitly associated with the subnet called public, and that the association in place and a route also in place. What does that mean? Is that we have subnet association with the public subnet and routes called out to go allow us to go anywhere on the internet. So what we just did is completed this cabling, so that we can now connect to this machine, because there is a route. One is the local route, which allows any machines here to go connect to anywhere within the VPC, and a global route to go anywhere you want on the internet using the gateway. With that understood, this guy should connect now, and yes, it did. Let us say yes, and now we are connected to our own NAT machine. Here you can see the private IP address showing up, like already showing up here, 10.0.0.165, and the public IP address of that NAT machine is this. This is a Amazon Linux machine configured already as a NAT. Let's exit out of that. So we're back to our local computer. Now, having done this part, the next concept that I want to talk about is to have another machine created here. Let's call it M1, some machine here in the private side. This is where I would actually put things that I want to keep them secure, away from random bad people on the internet attempting to connect to this. This is where I keep my gems, my goodies, my stuff in here. And so I don't want these bad people to connect to there. So what I will do is when I create a route table for the private route, I will not have a direct connection to the gateway at all. I will go through the NAT, not go directly through the gateway. That's the concept that I would like to demonstrate in this next idea, which is creating a second route table for here, and filter and create a private route table in my VPC, and then associate it explicitly with the private subnet, and then look at the rules of the table entries here. One entry says you can go whenever you want within the VPC. That's fine. I'll expand and add a route to go anywhere on the internet. I do want these machines M1 and M2 and any other machines here to be able to go to the internet, no doubt, but don't go directly connect to the Comcast modem. You want to go through the NAT machine. That's the idea. So what I want to be able to do is allow connection, but only through the machine I created, instance that I created, like that. And that's my NAT router that I created. It's available as a choice for target. And then I save. What does it do for me? It creates a route table, another entry that allows the machines on the private subnet, on this private route table associated with the private subnet, associations with the private subnet in my VPC, to go anywhere on the internet but go through the router, and that is active. Don't go directly through the gateway, go through the router. That's the key distinction between, or the difference between what is called a public versus private. This area, just because you labeled it private, doesn't become private just by labeling. It has to go through a NAT device to go outside on the internet. If you connect it like this directly to the gateway and not through a NAT, even though you call it private, even though call it secure, it's not private and not secure. Doesn't matter what you name it. It's how you wire it, how you connect the cabling. That's the idea. That's the idea. So that's where the route tables come into play. And we have a route table now, local, that allows any machine like M1, for example, to connect to any other computer within the VPC, and then you have a internet-wide access to these machines on the private subnet, but they need to go through the NAT route, not the IGW internet gateway route. Go through the NAT. That's the idea behind, putting NAT in before you go out to the internet, so that you bad people cannot access your internal machines. So having understood this idea, we'll double check our private RT here. This is the do not use, so ignore that. Private RT, we have a subnet associated with that, which is this one, is the private one. Then we have routes. There are two of them. One goes through your ENI, which is the machine that we created which is also the network interface for the NAT machine, which is, you can see it in EC2 dashboard. It's kind of, once you get familiar to the navigation, until that time navigation can be a challenge, and I understand that, but as you practice you will understand where things are with various clouds, and it is such a clumsy, cluttered interface that people find it daunting. And so don't worry, everybody's like that. Even Amazon employees who work on this, and even people like me, find it daunting. So there is a search bar. You can actually use this EC2 and then get to the EC2 service to find where you need to go, and that's your NAT router that we have. Now that's the machine I'm talking about, and this is how you're connecting through the NAT to the M1 machine that you will have. So I'll now create the M1 machine. M1 machine can be any machine you want, and it's available in the selection of choices. So you launch an instance and you basically select any operating system you prefer, and you connect, use that image to instantiate or create a new computer like this M1, for example. So now, before I jump into that, I want to tell you one more key idea, and that is about this NAT device. This NAT device will not function like a NAT device until you do one critical thing, and that thing needs to be done in the EC2 section on the machine itself. Like on this machine, you have to configure a property about that machine in the networking section. You need to go modify this change source destination check. That needs to be disabled. Or rather stopped. The words of choice used to be disabled, now the words are stop. So if this is a NAT instance, you must stop source destination checking. A NAT instance must be able to send and receive traffic when the source and destination is not itself. Now this is something to understand. So let's go first stop the source destination checking. Source and destination checking basically means each instance performs source and destination checks by default. The instance must be the source and destination for all the traffic it sends and receives. But you want to not do that when your computer is a NAT, because NAT by definition is a liar. Yes, the right word for this is, now don't get me to liar.com, that's a different idea. Don't go there. You can go there, but I'm not going there. Liar.com, it's a political joke. So by liar, what I mean is so I think Google searches will not help me. I'll just describe the idea here. A NAT basically pretends that it is somebody else. It's masquerading. That's the right word for liar. NAT masquerades as somebody else. What does that mean? Let's go see that. The word is masquerade. And that's what I mean by lying. A NAT device basically, so for example, here in your home, you are sitting here on the Mac, say M1 Mac for example, and you go through your router and go to CNN.com or FoxNews.com, any of these dumb news sites. So this traffic originates here, your browser on the Mac, M1 Mac. It goes through the NAT, and That's how you wired it up, right? It doesn't directly connect to your gateway. And then NAT sends the traffic to CNN and outright lies to CNN or Fox News that you are that it is the M1 Mac. It is not. It is lying. It is masquerading as if it is the M1 Mac, but it is not. So when the response comes back from CNN, it reaches the NAT, because that's where the traffic originates from. But apparently it knows that the traffic actually came from M1, so it passes on the packets to that machine inside M1, inside your home in the private area. Let's go draw this slightly more clearly. So I will change my screen layout a little bit, maybe this way. So your machine, M1 Mac, sends a packet request to the router. The router pretends to go to, say, CloudGenius website. So M1 Mac, Firefox browser, for example, and you send a request to the router passes it on to CloudGenius website, and router says, I am the Macintosh. No, you're not. That's masquerading. So the traffic that is supposed to be received from the router, like this is a request for information to this website, the website will respond back with a response, and that response needs to be rendered on this machine and not here. So the traffic that originates from here needs to go back to where it's supposed to begin from, but that's not the idea. And that's what we want to break in source destination checks. We want to disable or stop the source destination check. That's the underlying idea here. You want to stop it for source destination to be not checked, specifically when the device is a liar or a masquerader, and that is clearly called out here. If it is a NAT instance, you must stop the source destination checking. A NAT must be able to send and receive traffic even when the source and destination is not itself, because you know it is a liar, and masquerade is the technical word for the same thing. Masquerade is the word, and here is Wikipedia. Where is Wikipedia? So go search Wikipedia, read about masquerading, and you will understand. I'll just save it. So that now enables the NAT to function like a NAT. Without this change in setting that you will see again here hidden in the actions, networking, change source destination check and stop it. That's important. Without that, the NAT will not function like a NAT. Okay, next. The next idea is we create a new machine inside in our private segment. So that means I need to go to the EC2 section, and this time I want to create a new computer. So I launch a new machine running Ubuntu server, T2 micro. I need to make sure that I select the right VPC, make this instance go to the private segment, and then make sure that I do not get a public IP. It is different from what we did for the NAT. Opposite. We don't want a public IP. So we disable automatically assigning a public IP to the machine inside, because we don't want it to have a public IP at all. Yes, this machine will not get a public IP, only private IP, and will be able to connect only through the router. And that's what we are requesting right here. Disable issuing a public IP. I don't want it. Now you will question, how will I connect to it if you don't have a public IP? How will I connect to the internal machine M1 inside? We'll talk about that in just a moment, but let's go see what do we need to do next. We'll choose the GPT-3 SSD GP3 SSD, and then skip tags, configure security groups, create a new one. We'll call it applications or application servers. Actually, you can call it whatever you want, because this naming is basically for you. What do you want this to be able to respond to? Is to be able to respond to SSH request as long as it is originating from the NAT security group. So any machine that comes from the NAT should be allowed inside. Allow access from NAT. That's one rule that you want to put. The other rule you want to put is to let these machines go out to wherever they want. And so that we can modify the rules later on. I'll just go with this one rule to allow access from the NAT right now. So just very narrow scope, allowing SSH access as long as it originates from the NAT device. You see, the source is NAT, that one, that security group. Anything that is in the NAT security group, which is the only machine we have here, and that's the one that will be able to access the machines inside in this security group called application servers. So now we go review and launch. This machine is going to be an Ubuntu machine. I will launch it. I'll use the same public private key pair called Amazon and launch it. The machine should be ready in a few. And that machine is going to be this M1. It's a Linux computer, Ubuntu Linux computer. And so we'll call this M1. That's just a name. Save. It is pending right now. We'll clear it, refresh it, and see what happens. Whether it comes up, it should. It's pending. It should take a minute or so, and then this machine will be live. It will not receive a public IP at all, because we said don't give us any public IP. All we get is the private IP, which is fine. Totally fine, and we'll make use of that IP address and we'll connect to it through various ways. First way will be going through the NAT, and we'll see how things work in this context. And then we'll talk about advanced SSH configurations to connect to it without worrying about the NAT or any other things. So we'll simplify things as we go along. Let's wait for the machine to get up and running. Is it running now? I think it should be. Yes, it is initializing. Status checks are finishing up. But if you copy the IP address here, private IP, you try to connect to it, it will not work like that. By the way, the username for Ubuntu machines is not EC2 user. Not. It is Ubuntu. And then you can type in the private IP. This will not work because there is no route to it. There is no way to get to that 10.0.1.91. It's not routable. It's a private address. It's definitely not routable from my home or my favorite Starbucks location. I cannot connect to this machine like that using that private address. I need to go through the router. So now I'm on the router. I can potentially still not going to work, but here, and then put in this address, and this will attempt to connect and fail. Why? Because we don't have the key pair, so it failed. So we'll put our key pair in the router box and then connect to the internal machine inside, and that should work. But there is a problem. The problem is you have to put your private key pair in that machine, and private key pair should not be used like that. So you can potentially take your private key from your local computer like this. You copy your private key and then put it inside your machine out there in the NAT machine, and that is one way to work around, but that's a security concern. You don't want to put your private key out to a machine in the cloud. So then how do you solve it? You still want to connect to the machine inside, but you don't have the public private key pair combination on the NAT machine because that's where the permission was denied. You tried to connect, it kind of sort of attempted to work, but then denied. And then it's a chicken and egg problem. How do you break it? How do you get inside the machine, internal machine M1, without giving your private key out of your local computer? Your local computer is this machine where your private key is sitting like right here, and you don't want to give it out to anybody ever, not even your own NAT. Yes. So then how do you break it? I want to be able to have a way, and that way is available through SSH proxy command. And let's go see if we can find some quick examples of how to make use of that. I think this would be a good one. Yeah, I think these are good ideas. So let's go try them. So what I want to be able to do is take some examples, modify them, and customize it to our context. So in our context, what we have our host name inside will be called M1, and its IP address is going to be, we know that already, 10.0.1.91, I think. Isn't it right? I think so. Yeah, there. So 91, 10.0.1.91. Then username inside is not Vivek, but Ubuntu. And then identity file is located in my computer, which is I think this is not a good example. So let me find a better example. The better example you can find is in CloudGenius website. Let's go there. CloudGenius website, programs, bootcamp, or seminar will have it. Let me see where we can have it. Begin. I'll search it and hunt it down to get to the right spot where we can find it. There is a short piece of code that I'm looking to hunt down. It might be in my local computer. Let me just quickly check. Do I have it? I think so. It's right there. So let me export that out. And here is an example that should work. So I'll copy it, put that in a notepad where we can make use of it, and then grab the corresponding entries that we want. Let me put this on the side and put this on the other side here, and make sure we grab correct entries. And those entries that we need are the name of the computer out there. It's called the NAT machine. It has an IP address with that number, so we'll put that IP address right there. Then we have a username inside called Ubuntu. Strict host checking is okay, and that should be the configuration that we want, and that will allow us to get into internal machines inside. And so let us see if we can play with that. So I'm going to copy this. There is one more piece of the puzzle, I believe. No, this is not complete. There's one more missing piece. Let's go Google. Let's see what Red Hat says. Yes, that is a good one. So let's go create that configuration. The Bastion host nickname, Bastion host hostname, the remote host hostname, nickname, and the remote host hostname. Bastion host nickname is NAT. That's hard-coded proxy. That's a soft modifiable proxy command. So let's go use that instead. Remote host is not happy with it. Not happy. I think I'll just play with and figure out what's the right answer. So let me just experiment, and that is the best way to figure out things. So the NAT host, that part is correct, this part is correct, this part is not necessary, and let's go put these lines in our context. And proceed. So I'll copy this context, put that in our SSH config, which is this file here. So I'm going to open it, modify it in the configuration, and drop entries in there just like we have here, and attempt to connect. This should attempt to connect properly, and if we see some errors, we'll fix it as we iterate through the process of getting the SSH configuration correct. And once I resolve it, I'll be able to write things down and I'll put that in the website, so we will have a good way to hop through the NAT into the machine inside. Let's go see how this thing works. First SSH, and then EC2 user, followed by NAT. This should work. Yes, it did. Nice. Then we'll modify, add a username, EC2 user, and that should simplify even further. So then I should be able to say SSH and NAT, and that should connect. Yes, it did. Then what I will do is SSH and then say M1. M1 is not known, so you have to put the IP address first, like that, and it did not. It refused the connection because it doesn't know the hop. The hop name is not specified, and the hop name needs to be specified, and I'll elaborate. Let me just finish the fixing this issue that I'm running into, and that should allow us to connect to the machine inside. No route. One more try. No route. So we need more investigation. But there is a technique. So we'll have to hunt it down. Let's go see in Stack Overflow. Stack Overflow is always the best way to figure things out. If you don't find the answer, they usually have it, because SSH proxy command, config file, example. Yeah, that's the challenge with open source. Nothing is clearly called out. So we have to hunt and get to the right point. I think this looks like a decent answer, but we have to experiment. Another good way would be to actually go read the documentation for SSH config, which I'm going to resort to ultimately if nothing works. But this is the cheat way. The cheat way is the easier way. So let's cheat. I have it written somewhere, but where is that? That's the part I'm trying to find and hunt it down. Let's see. I think it should be on my website somewhere, but the challenge is finding it. So I will go and do it. I'll find it down. That's the only way. Sucks. Cannot find it. So hard. I think I need to improve my search capability in the website. It has become a giant jungle. So hard to search. I need to work on that. So I think there's no point searching for these things live in a live session. So what I'll do is do this in a separate session, and I'll pass on notes once I figure things out. I'll pass on notes in Slack chat. But what I would like to do is the cheat way. The cheat way would be to use this public private key pair that we have, and this is bad idea. So don't do that in production, but I'm going to copy my public key and I'm going to connect to the NAT machine there, and I will create a folder. In that folder I will add my private key into that NAT machine. This is a bad idea, don't do that in production, but I'm going to just finish off the concept. So here is the key that I want to add inside. This is the private key that I exposed to you. I shouldn't be doing that either, but I did. And then I'll make sure that I secure the private key, and then I should be able to connect to, this is on the NAT, so I should be able to now connect to the machine inside. 10.01.91 still denied public key. That is strange. But do I have a way to connect to that machine? I do. So I think this hack based method is not the right approach. I will break the session right now. I'll continue my research and investigation. I'll put this in our Slack chat, and we'll do the rest in a subsequent session. With that, I'll break the recording.